स्क्रीन मोड ऑन कर दो। हेलो। म्यूजिक के अलावा मुझे कुछ नहीं सुनाई दे रहा। म्यूजिक की आवाज अच्छी आ रही है, आपकी आवाज बिल्कुल कम आ रही है। कौन सर ने ज्वाइन किया क्या?
Hello. Good afternoon, everyone. Please stay connected. सर आपकी बोल रहे थे Please stay connected as we'll be starting our program at 3 p.m. sharply. Participants are requested to mute their mic, please.
Participant. उसमें लिखा है कि you are muted. Okay. Kole sir, good afternoon. This is Vinay Thapar. Kole sir, can you hear me?
Yes, I can hear you.
What a pleasure to see you after around a quarter of century.
Yeah, it's a long time.
Yes.
We have not seen each other. I hope everything is going okay there.
Fine by the grace of God, sir. How are you, sir?
I'm very good, and you?
Fine, sir.
Very good.
Absolutely.
So, are you in RJPV now, or how? Earlier, I remember that you were in the government engineering college.
Yeah, actually, the same college has been taken over by RGPV. So it is
Okay.
now Constituent College of University of RGPV.
Very good, very good. So it means that then your services have been transferred to RJPV.
At present, sir, we are on notional deputation. We
Oh,
continue to be government servant, so we have that privilege of government job. Yeah.
So that's very good. Yeah.
So now you have traveled whole world now.
Yeah, not too much, but yeah, I will share my academic journey with the participants also. So it has been a long journey, basically. Long academic journey.
Yes, sir. And kindly accept my condolences, sir, on the demise of your
Yes,
father.
due to that, I was little
And that
in a difficult situation.
Katie told me, so
Yeah.
yes, extremely sorry, sir.
No problem. Yeah, but it's really difficult to. Yeah,
Yes.
but you know that. Yeah.
It's part of life, sir.
Yeah.
Everybody has to go through it.
Yeah.
Good afternoon, sir.
Hello, Katie. कैसे हो?
Fine, sir. Fine. Thank you for joining us, sir.
Very good. Yeah. I hope my video is coming okay, right?
It is
And
very
the voice is also okay.
Afternoon, sir.
So we have participants from all over India, or only from Madhya Pradesh or in Bhopal? How it is?
Sir, it is bulk of participants are from Madhya Pradesh, but there are few outsiders also.
Very good. Yeah. And I believe that mostly from electrical engineering background or different multidiscipline.
It is multidisciplinary, sir.
Very good. So because of most of my projects or the research work, it is covering multidiscipline. So that is really good. Yeah.
Sir.
So you people are working from home now, or how is the situation?
Yes, sir. Most of the time we are working from home.
Yeah.
We are taking online classes, and few times we are required to go. Otherwise, mostly from working from home.
Yeah, but it seems like now the situation is getting very bad now.
That is correct, sir. But then India is opening up.
Yeah, and it seems like an exponential growth now.
Yeah, exponential growth, and then actually it is the time when we should have the lockdown.
More restriction, yeah, at this moment.
Yeah,
especially at this moment, because we had to drop the peak, or we had to put some damping on that one. Otherwise, it will just go up.
Yes, sir. So we are heading for a bad time, it appears.
Yeah. Because if we see our control system, right, and we have the transients, and we don't put the proper damping effects, so it will go to the unstable situation, right? So here we need now some damping effects.
That is correct, but the chances are very bleak. They have removed all the dampings, no restriction. Other than educational institutions, almost everything, every commercial activity and all activities, they are open.
May I start now?
I think you can. Sir, should we start?
Yes. I think we can start here. So, and then if there's some people they are coming, they can join also. Yeah, no problem.
So, Vanna, you may.
Good afternoon to our eminent guests and all the distinguished participants with great joy and immense exultation. I feel privileged to extend my warm welcome in FTP on application of soft computing techniques in engineering optimization under TechUP organized by Electrical Engineering Department, UIT RGPP Bhopal. Today, we are pleased to welcome Professor Dr. Mohan Kole, sir, from University of Agder, Norway, an eminent faculty of engineering and science as full professor in energy systems engineering with focus on smart grid and renewable energy systems, head of energy systems group, technical manager of EU SP7 TEMA project. He has also received the offer of absolute professorship in smart grid from the Norwegian University of Science and Technology, NTNU. Professor Kole has more than 25 years academic experience at international level on electrical and renewable energy systems. He is a leading renewable energy technologist and has previously held academic position at the world's prestigious universities, example, University College London, UK, Australia, Hydrogen Research Institute, QC, Canada. Professor Kole was a member of the Government of South Australia's first Renewable Energy Board from 2009 to 2011 and actively contributed on developing renewable energy policies for South Australia. Professor Kole's academic work ranged from the smart grid, grid integration of renewable energy systems, energy storage, electrical vehicles, home energy management system, integrated renewable energy systems for hydrogen production, techno-economics of energy systems, solar and wind energy engineering, development of business models for distributed generation. Professor Kole has been successful in winning research funding from prestigious research councils, example, EU Norwegian Research Council, EPSRC, BBSRC, Northern Research Partnership Scotland, etc., for his work on sustainable energy systems. He has been published extensively in the area of energy systems engineering. He has been invited by many international organizations for delivering expert lectures, courses, keynote addresses. He has also been a member of many academic promotion committees as well as expert member of International Research Council. And today, he will be sharing with us his findings and expert opinion on the smart grid, intelligent computing techniques for increasing penetration of sustainable energy technology. We feel honored to have with us the honorable guest, Professor Mohan Kole, sir. There's request from the participants to keep their mic and camera off. If you have any queries during the presentation, please type them in the chat box. We'll bring them up at the end. I'm sure we'll be enriched by the session. I welcome you, sir. So please, may I request you to continue?
Good. So thank you very much for a nice introduction. Now, are you able to see my screen or it is coming the double screen? Now?
Yes, it is visible.
Are you able to see my screen? Only one screen or multiple
Yes, sir,
screens?
the single screen. We can able to see.
Yeah, because earlier when we tested, so there was some problem. So that's why I want to make it sure that. So good afternoon to everybody. And it's my pleasure to be with you in this faculty development program. And RGPV has requested me to share some of my time with you by contributing, giving some focused lecture on smart grid, where we can use intelligent computing techniques. And first of all, I'm very much thankful to Dr. Vinay Thapar and Dr. Krishna Tirath Chaturvedi for organizing this faculty development program. And during this my personal difficult time, I accepted request from Vinay and Krishna that I will try my best to share my knowledge and experience with all of you. So today's lecture and tomorrow's also, I'm dedicating to my father, who has recently passed away on 24th August. And he was a primary school teacher, and he has given me very good support to reach this academic level. So before going into the details of the lecture, because what I have been briefed that many of you are young professionals or started your academic career just now and quite keen to work on renewable energy system, or maybe make it more focused like sustainable electrical energy systems. And in sustainable electrical energy system, how we have to include multidiscipline together, that I want to share with you. Okay, so before sharing the details of my projects, okay, first of all, I will like to share with you my academic journey. So at this moment, I am working as professor in smart grid and renewable energy at the Faculty of Engineering and Science, University of Agadar from June 2012. During my professorship at the University of Agadar, I had the opportunity to lead the research projects on multidiscipline energy system, where we are using intelligent computing techniques on optimization of renewable energy systems within the distributed network, as well as utilizing the information communication technology infrastructure for energy management and energy efficiency approaches also. And here at the University of Agadar, I had 5 PhD students. They are working with me. One of the PhD student, he is working on machine learning applications on smart energy warehouse. So here in this project, or in this PhD work, which is funded by Research Council Norway in cooperation with the industry, Rema 1000, which is the biggest shopping chain in Nordic countries, especially in Denmark and Norway. It's a very big shopping chain. So they provide all groceries and everything, and at a very reasonable price, so they are quite popular. So they have very big warehouses where they are putting all the foods at an appropriate level, at appropriate climatic level, I can say. So due to that, they need a lot of energy consumption. So in this industrial PhD project, we are utilizing the real operational data from the smart warehouse to intelligently manage the operation of the refrigeration as well as the air conditioning, and also at the same time utilizing effectively the production of building integrated renewable energy sources and reducing the demand on the main grid. Okay, so here you can see that we are doing the PhD here, or my student is doing the PhD on this topic. It is an industrial PhD, not funded by the university. It is funded by the industry and the Research Council of Norway. And the topic is quite industrial oriented, where we are utilizing the intelligent computing techniques for optimization of the energy management of the smart warehouse. He has completed 50% of his work. 50% of his work is remaining. During his 50% of work, we have published many articles which provides how the real-time data, especially from the refrigeration system, how they have been used for energy management approaches. Okay, so that is a one project which is quite relevant to the key topic of the FDP. Then another student who is doing the project that is really interesting. He is working on how we have to do, or how intelligently we have to optimize the charging process of the electric vehicles in the parking lot, considering the grid constraints and the demand limit of the parking station at a particular location or at the particular parking place. So that is again very interesting project where we are utilizing how we have to effectively manage the charging of the multi electric vehicles with different capacity, with different preferences, and then how we have to develop the or how we have to optimize the energy management strategy based on the demand of the individual electric vehicles, as well as considering the incentives they want to pay, right? Whether they want to go for the fast charging or the slow charging, and how we have to manage that. So that PhD work is also going with me. Then another PhD, which is funded by Royal Norwegian Embassy, New Delhi, under the framework agreement between the Norwegian Foreign Ministry Affairs, TERI, New Delhi, and my university. And under that project, I have one PhD student who is likely to submit his thesis next month. And in that work, we are trying to consider that when we are increasing the penetration of solar photovoltaic system within the distributed network, then how we have to develop smart microgrid architecture, considering the intelligent techniques or considering the real operational data and the demand side management also, and at the same time the grid constraints, and based on that how much appropriate energy storage can be used, as well as the another distributed generator. So to make this microgrid more operational as a active generator, which we can provide dispatchable real power and the reactive power. So here in this project, PhD project, which is again externally funded through another project, right, not from the core budget of the university. So here you can see that how the intelligent computing techniques have been utilized for promotion of solar photovoltaic system, which have been integrated within the distributed network, so that that distributed network can operate as a smart microgrid, and within that smart microgrid how the intermittent renewable energy sources, for example solar photovoltaic system, can be considered in cooperation with effective energy storage as an active generator, so that they can provide dispatchable active and reactive power within the smart grid or within the distributed network for improving the power system stability. So these are the some of the key projects which are quite relevant to the faculty development program objectives. Okay, they are ongoing with me. Okay, and then another very interesting project which have been funded by European Union Framework 7, and that project was scalable energy management infrastructure for aggregation of households. And in that project, the idea was that how we can utilize the information communication technology infrastructure in a centralized way for reducing the peak demand of a selected non-critical power intensive load of the houses, and at that same time integrating the production of intermittent renewable energy sources by utilizing the virtual power plant approach. So this topic or this project experience I will share with you in tomorrow's lecture. Okay, so those are the key work which I am doing at the University of Agder, Norway. And before coming to the University of Agder, Norway, I was working as Director of Program at University College London, and I had the responsibility to establish University College London School of Energy and Resources in Adelaide, Australia, in cooperation with the industrial partner, like for example BHP Billiton, Santos, and Adelaide or South Australia government also. So when I was working as a Director of Program at University College London, I had the opportunity to be the board member of South Australia government's renewable energy. And while working at UCL and South Australia government's renewable energy board, I worked on not only on the technologies, but also developing renewable energy policies for promotion of sustainable energy system within the South Australia government's network. And that work has been very useful not only for the South Australia government, but also for me also to learn that how the developed countries, they are developing the policies or the energy policies in cooperation with industries, and how the academic inputs have been integrated in the policies. That have been very key point for me to learn and also to share with you. And you might be aware that University College London is one of the prestigious university in the world. It is always ranked under 10, and around 30 alumnus, they have the Nobel Prize in different disciplines. And at the same time, you may be aware that Mahatma Gandhi as well as the Rabindranath Tagore, they were the alumnus of University College London. So here I can say that while working at the UCL, I had many things to learn, and the learning was that how we can integrate our different discipline together for achieving sustainable development goals of the United Nations. And that we achieved, and that I had achieved while working at UCL and the South Australia government's Renewable Energy Board. Here I will like to give you one example. When working at the Renewable Energy Board, we set the target that in 5 years' time, South Australia government is going to have the renewable energy by energy contribution by 20%. But while working on the policy and requesting investors to invest in the renewable energy sector, we achieved that target of 20% within 1 year. And now it is around 50% of the electrical energy is coming from the renewable energy sources in the South Australia. And you might have seen that due to this increasing renewable energy penetration, the electrical energy pricing in the South Australia, sometimes it goes to the negative also. Okay, so here you can see that how the academic inputs have been integrated in the government policies also. And then when we are integrating our academic inputs or academic knowledge also, so then not only the technical things, but we are integrating that. Let's say the main objective in South Australia was that to integrate the wind farms. So when we want to integrate the big high capacity wind farms within that network, so we have to see that how intelligent computing techniques can be utilized to overcome the intermittency of the renewable energy sources, and how we have to modify the operational functionality of the dispatchable power sources so that they can provide the instantaneous power without compromising the power quality or the stability of the network. So we worked on that also. And then at the same time, then of course, when we are integrating the wind farms within the electrical energy network, then we have to see about the economics also. So I was responsible at the South Australia that how we have to develop or how we have to modify the business models when we are integrating the wind farms within the network, right? So what type of business models should be there so that the investor can invest into the wind farms, and then at the same time how the conventional power plants, they can also get benefited from that. So here you can see that I had a good opportunity to learn from this work which I did there, how we have to develop the business models considering the market dynamics as well as considering the technical capability of the conventional power generation sources as well as the energy availability from the intermittent renewable energy sources, for example, the wind farms. So for that, you can see that it is not only just the electrical energy, but we used all computing techniques for prediction of the intermittent renewable energy sources from the wind farms. Okay, one point. Second point, then how we have to develop the intelligent controller for the conventional power plant to overcome the intermittency of the renewable energy sources, or to provide the inertia within the network for making the system stable, right? So I had the opportunity to learn that, and maybe some of you, if you are interested in working on this topic or want to do further research work, I will be very happy to collaborate with you or to provide you further inputs based on my learning. Okay, so now I will move backward, maybe I can say. So before moving to University College London, I was working as a lecturer at University of Dundee, Scotland. And there I had the opportunity to develop undergraduate and postgraduate program in renewable energy, and which had been very successful, and especially for the industry professionals' point of view. So when I was at University of Dundee, and when I developed this bachelor's program and the master's program, so I used the curriculum design policies or curriculum design structure in such a way that the candidates or the students, they have the flexibility to select the appropriate credits. Okay, even they can come out if they don't want to complete their masters, maybe due to some reasons, so they had the opportunity to come out of the program by, for example, by taking a certificate or maybe diploma, or maybe postgraduate diploma, or maybe with complete postgraduate degree also, depending on how many number of credits they have completed. And then we also provided the flexibility. If suppose some industry professionals, they want to not only to specialize only on the technology side, but they want to go on the energy policy sides, or they want to go on to the energy economic side, or they want to get it focused on a particular energy technology also. So then that flexibility also I had included in designing this master's and bachelor's program at University of Dundee and Scotland. You might have seen that the government of India has introduced new education policies, and I'm very happy that some of the points which I had covered while working at University of Dundee, they have been included in this education policy. So I'm very happy with that one. Then, before coming to University of Dundee, Scotland, I was working at University of Glasgow, Scotland. There I was a research director, and my objective was that to establish renewable energy research, education, and demonstration project. So then for the education category, I also developed one master program where we have the multidiscipline approach. The same, like for example, someone want to have maybe more from the economics and social sciences background, someone who is interested more on the technology side, someone who may be interested more on the fundamental science side also. So that we integrated there. And then at the same time, the another work which was from the demonstration point. So from the demonstration point, how the renewable energy technology demonstration can be done in cooperation with the local industries or the local communities. Okay, and then the data which we are getting from this demonstration system, a practical demonstration system, how this data can be used through machine learning approaches or maybe through artificial intelligence approaches, right, for predict not only for the prediction of the intermittent renewable energy sources, but utilization of data for managing the production of conventional power plants, one point. And then second point, how this data can be used for developing the intelligent controllers also. Then another very interesting project I will share after some time also, that let's say if when we are talking about the renewable energy sources, we are talking about the intelligent soft computing techniques also, we are talking about the intelligent controller also. So then of course when we are talking about a sustainable energy system, then we have of course the intermittent renewable energy sources are going to be there. So to overcome the intermittency of the renewable energy sources, we may need to include the energy storage. Okay, so how the energy storage can be included there. Okay, how the sizing of the energy storage can be optimized with reference to the intermittency of the renewable energy sources, as well as with reference to the intermittency of the load demand, as well as the availability of the conventional power plant. So in this work, or when I was working at University of Jyväskylä, Finland as a research director, so we used very different approach. We didn't consider the energy storage in the battery bank as in conventional form, but we consider the energy storage from the long-term point of view, where we can store the energy in the form of electrolytic hydrogen. Okay, so that one was quite interesting also. Okay, I will share that experience with you. And before that, then I was working in Canada as a research fellow at Hydrogen Research Institute, and there my objective was like how we can integrate intermittent renewable energy sources. Okay, one point. Second point, how intelligently we can connect these devices on the DC bus, or making it more as a DC microgrid. So you can see that on the DC microgrid, which is picking up now, I worked on that in 2001 and till 2003, and developed one real demonstration system. And on that DC microgrid system, we considered very innovative approach that how we can store or how we can use the electrolytic hydrogen as a long-term energy storage, and then how we can utilize that long-term energy stored in the form of electrolytic hydrogen through fuel cell by providing intelligent power conditioning devices, so that that fuel cell can produce the required electricity for fulfilling the load demand, and at the same time how that fuel cell excess heat can be utilized for heating purpose, because that system, it was in the Canada, and we know that in the Canada the temperature drops till -20, -30 degrees centigrade. So we need to have the heating. So how such type of system can be worked as a combined heat and power system. So here now you got, and before that I was in India, and earlier I worked on solar photovoltaic system also, solar photovoltaic water pumping system also for sustainable development, and so on and so forth. So in brief, now you got some idea that what is my academic expertise, or maybe in a simple way, what I have learned through my academic journey of last 30 years, and how this my academic journey of 30 years, or maybe my learning from the last 30 years, okay, it is all continuous learning, how you can utilize to enhance your learning or to gain the knowledge, that you have to identify now. Okay, because now you know that many of people, they may be working in different areas, and some of you may be finding some of my topics quite interesting for you to do further research work, or to develop your academic credentials, or to develop your academic knowledge in a particular topic. So here you can get the idea that how I can help you, or how I can share my learning with you, right, related to the intelligent computing techniques for promotion of sustainable electrical energy system. Okay, so just now I have given you some of my background. So are you able to understand, or are you able to hear me properly? Hello? Everybody is able to hear me properly?
Yes sir, we can hear you.
Yeah, because sometimes we in this digital mode, we have to be very careful. Otherwise, I mean, if I might get lost
No
my
sir,
connection.
don't worry, we are here. If there is any problem, we let you know.
Very good. Yeah. So now moving towards the projects now. So I have shared you my academic experience, And you might have seen that I work on very different projects. So all these different projects, right, they are not funded by the universities from the core budget. They have been funded through competitive research grants, or means through open competitive applications. So here I have listed some of the funding bodies through which I had received funding. The first is European Union's 7th Framework Program. That project is titled as Scalable Energy Management Infrastructure for Aggregation of Households. In that project, the objective or the target was that how we can utilize information communication technology infrastructure for reducing the peak demand within the distributed network by considering non-critical power intensive load. Okay, the details about this project with findings I will share with you in tomorrow's lecture. Okay. Then another project which has been funded by Norwegian Research Council, that again through competitive process, and we submitted the proposal and we were lucky to receive the funding. And the funding was that how we can build zero energy buildings in a particular area. And when the people are living in those zero energy buildings, how those zero energy buildings are going to behave, are going to interact within the distributed network, that have been the key objective of this project. Okay, I will share that with you also. Okay, so that was quite interesting. And then here you will see that when I am talking that the zero energy building, grid integrated, and how its operation or the performance is interacting with the grid, then of course we need to incorporate many intelligent devices also, and then we need to do the lot of data analysis, soft computing, and based on that then we have to propose some optimization methods for reducing the intermittency of the renewable energy sources which have been integrated in those houses, right? And for that, how we can have the appropriate battery energy storage, its operation and management also. I will share some details about that project. And before that, when I was working at the University of Dundee, Scotland, I had the opportunity to make one application to Engineering and Physical Sciences Research Council. We call it EPSRC UK. And that funding was around 1.8 million British pound. It's quite big grant. And that project was also in cooperation with India, TERI University and TERI Research Organization. And the idea was of that project, it was that if we want to develop off-grid renewable energies based system, so how we have to optimize the sizing considering the local resources, then at the same time when we are considering the local resources, optimizing the sizes, then how we need to develop the business models for such type of system for further promotion. So that had been considered in this EPSRC funded project. And that project was for 5 years and it was successfully completed. So all the projects, they have been successfully completed now. Okay. Then another project when I was working at Finland, that was funded by European Union Regional Development Fund. And in that project, the idea was that how we can do the renewable energy demonstration. Okay. And not only the demonstration, but the important key point was that to collect all the data from this system, analyze that, and based on that, okay, provide some operational scenarios and provide some intelligent controllers also. So that we did when that I did when I was working at University of Jyväskylä, Finland. Okay, and then when I was working at the University of Dundee, Scotland, there were two projects that those were also quite interesting. Maybe some of you may be interested in that project. So those were funded by Northern Research Partnership Scotland. Two PhD students have been supported through this project. And the idea was that when we are talking about hydrogen economy or clean transport, then maybe after some time, we may get the fuel cell vehicles onto the market. So how the fuel cell dynamics are going to be impact, okay, or load dynamic, make it simple, how the load dynamics are going to impact on the fuel cell operation, proton exchange membrane fuel cell operation, that have been covered in this Northern Research Partnership Scotland. So I have worked not only on the research projects also, but also on the education project also. That is a lifelong learning program of Erasmus. That how we can train or how we can educate the next generation professionals, okay, on promotion of building integrated renewable energy sources. And then when I was working in Canada also, so that project, it was funded by National Research Council and NERC Canada also. Then three small projects which is ongoing with me as almost completed now this month, right? They have been funded by Indo-Norway Collaborative Research Grant through Norwegian Framework Agreement. And under that project, one project I already explained you about, that microgrid architecture, but two remaining projects, they are quite interesting. One project, it is related to the recycling of solar photovoltaic panels and the batteries. And another project, it was more from the rural development point of view, how we can use the biomass gasifier with combined with organic Rankine cycle engine for production of electricity and the heat. Okay, so that has been again a very interesting project. But here you can see that in all of the project, they are multidiscipline, and in most of the project, we have to use the intelligent techniques, we have to use the computing techniques for proper integration of the sources and the like. So now you got the idea about my background. Now you got the idea that to continue the research work or to do the research work, how we have to get the research grants from the funding bodies through competitive process also, right? So it is not that, yes, I want to do the work on this topic, just give me the funding. So it is the work doesn't work like that in the most of the developed countries or in most of the universities. Let's say I have the good ideas, right? Then I have to identify the industry partners. I have to identify the collaborators also from other organizations who may have the expertise in different areas. So we have to make a proper matching between the expertise of the industries, academic organizations, and like that. And based on that, we have to make one appropriate, very good quality proposal, depending on how much technology readiness level you want to include there. And based on that, and depending on the call objective, we have to submit the proposal, and then through it goes through the all peer review process, evaluation process, and like that. And after that, if we are lucky and the reviewer, they accept our idea, yes, this is a really good idea and going to benefit to the society, not only the academics but also to the society also, then we get the funding. So I request you, if you want to do further research, always try to get some competitive research grant in cooperation with the industry, international partners, as well as the other research partners who may have the expertise in different disciplines, okay? And how we have to make a proper matching or the proper marriage between these different disciplines together. And based on that, then we have to see how what the output is going to be there from that project, at what technology readiness level it will be there. And then accordingly, we have to submit the proposal. So here, what I can suggest you, because many of you are quite young professionals or just started your academic career now. So you, while making your research applications or the research grants application or the research proposals, you have to think what is the requirement, how you can incorporate the industry, how the industry can provide the contribution there, how you can utilize the international cooperation or the collaboration also, and also the regional expertise, and at the same time how you are going to include the regional society also. That is again very important point, which I noticed that in most of the Indian conditions in the projects they don't include that. We need to include the society into the project. Means always we need to have the society participation in the project. For example, when I mentioned that the zero energy building project, so that is, of course, it looks like more technical, but we included the society. How we included the society? Those zero energy buildings, the people are living there. Okay, so their behavior is impacting the energy consumption of that renewable of that zero energy building, and due to that, whatever the data we are collecting from them, it is all changing. Then we have to see that if they change their behaviors, if other members from the society, they change the behaviors, then how the system is behaving, which type of electrical loads they are using, how it is impacting the power quality. And then we have to tell them, less if you behave like this, we are going to get that benefit and like that. So it means that in all research projects or all our academic work, we need to have more effective society integration. Then only we will be in a position, whatever the academic work or the research work which we are doing now is going to be beneficial or immediate beneficial to the society. Okay, so for that we need multidiscipline approach. Sometimes we may need to include the social scientists in our proposal also, because some social scientists, they are quite good in analyzing the data of the social behaviors of the consumers or the society also. And then for all that purpose, now everything is like, when we are collecting so much data, we have to use some soft computing techniques for the analysis. Okay, so those I have given you more like first I have given you my background, then how that research funding bodies are going to work, and then how we have to develop the research proposals, and how we have to train ourselves, or basically the objective is faculty development, right? So here we have to think like from your development point of view now. Okay, so how you can get benefited from this course, right, so that it can help you in your personal development or personal academic development. So when you have your personal academic development, so naturally it is going to contribute to the academic quality also, and of course to the society also. Okay, so that should be our objective. Now coming back to the my 3 projects which I want to share with you. Okay, that main 3 key active project which is ongoing at the University of Agadir. The first project is electricity usage in smart village Skarpness. That is a building integrated photovoltaic system. I will talk with you in much more about this project. Okay. Then another project, that is scalable energy management infrastructure for aggregation of households. That I will talk with you tomorrow, because that is quite big project, really very, very big project. It was around 3.4 million euro with 12 partners and 3 academic organizations and 9 industries. Okay, and it includes multidiscipline from ICT to the business model, the security and privacy, infrastructure, front and back end infrastructure, and like that. So it's quite a big project, and that project will really help you in understanding how we have to work in the multidiscipline team. So that I will share with you tomorrow. And then another project, that is a sustainability and clean energy project, which is ongoing, funded by the Royal Norwegian Embassy in New Delhi under the Norwegian Framework Agreement. Okay, so first project, like electricity usage in smart village Skarpness, that is a building integrated photovoltaic system. That this project, it is through innovation project in the business sector in the category of Energy X. Okay, and I hope everyone is in a position to listen me. Hello.
Yes, sir.
That's very good. Yeah. Good. So I will tell you here. This project was around 11 million Norwegian krone. And in this project, the partners were Agadir Energy, Teknova, University of Agadir, Altec, and the buildings which were built, they were by Skanska, which is a very leading building developer or builder in the Nordic countries. So especially for this project, 40 houses, they have been built by the Skanska, and the objective was the annual electrical energy consumption from these houses should have the annual electrical energy production using renewable energy sources, or through, for example, through building integrated photovoltaic system, or maybe heat pumps also, so that annual net energy consumption should be zero. That's why we define these houses as a zero energy building. And these houses have been built into the market and sold into the open market also. Initially, 6 houses, they have been purchased into the open market, and the people, they started living in those houses. So here you can see that these were the area where these houses have been built, and this is the map of the Norway. It is in the south of Norway, and this area is called Skarnes in Agadir region near Arendal town, and my house was somewhere here. I was living somewhere here, so it was quite near to my house also, this area. And this picture is from the summertime. In the summertime, you can see all the green and everything, very nice. But if it might have been winter time, then it might have been complete white here. Okay. So here, the 40 houses with very high quality thermal insulation and with all modern up-to-date equipments or the appliances, they have been used in these houses with very high level energy marking or the ratings. Okay. Similarly, for the insulation and everything, or thermal insulation and everything also. And in these houses, here you can see that university is involved there, utility means distribution company is involved there, okay, research organization is involved there, then another organization which produces the power conditioning devices is also involved there. Okay. In this houses, a lot of instrumentation, they have been integrated to monitor and to monitor and record the energy consumption of different power intensive appliances. Based on that, right, or based on the energy consumption data which have been recorded there remotely on a server, how they can be utilized by the utility company, okay, for finding out not only the power quality, but also predicting the behavior of those particular houses. So here you can see that it looks like a very simple, but the data which have been collected from these houses for individual power intensive appliances, right, how they have been monitored and analyzed for doing further operational or doing further analysis, considering that in future, if we are going to have a number of houses based on the zero energy building, so how they are going to behave within the distributed network. So for that, we used this university server for collecting all the data. Okay, then here you can see on the picture, we have the building integrated photovoltaic system. Okay, and then it was connected to the network. Okay, so basically grid integrated here, and here at this house we installed LSPAC Investigator. I hope that many of you may be aware about the LSPAC Investigator. LSPAC Investigator is one of the best device into the world at this moment. It is from the Israel, and it can provide you the information or the data at the minimum level of 20 microsecond. Okay, at the minimum level of 20 microsecond. And with that LSPAC Investigator, it has a so big computing power. It can provide you the analysis of the harmonics, maybe till the 12th or 15th of harmonics. It can provide you all positive sequence, negative sequence, zero sequence component currents, balancing also. It can provide the active power, reactive power, real-time flows. It can provide you the real-time changes in the power factor also. Okay. So it provides you n number of data at minimum level of 20 microsecond. When we are collecting that data from the real operational house of the zero energy building here, so then we need our computing techniques, right? Which type of load is creating the harmonics? Why it is, at what time it is coming? Which type of load, right, is impacting harmonics? Where we have the possibility to reduce the harmonics? Okay, how this zero energy building is feeding the power to the grid, how the voltage is changing. So it provides you all the factor voltage at 20 microsecond level, okay, current at the 20 microsecond levels, all balancing, okay, harmonics also. So here, one of my PhD student, he used all the data for doing further analysis. If you are interested, right, how the zero energy building is going to interact with the grid, then his PhD thesis is very good for you, and it is publicly available also. The candidate, he was sponsored by the Malaysia government and supported by this project also. So we were in a position to do a lot of detailed analysis on the power quality, grid interaction of zero energy buildings, okay, how the balancing of the loads has to be there, which load is going to impact the harmonics, okay, so all these factors. So all, then when we have all this data and analysis with you, then the utility company, right, which have been invested into this project, so their objective was that, like when we have such type of houses, and it's going to increase into the future also, so what type of precautions they have to do, what type of intelligent devices they have to develop to improve the power quality, one point, or maybe to increase the penetration of such type of houses within the distributed network, not only from technical point of view, but also from the business point of view also, because such type of houses are also going to impact their business models also, okay. So how they have to modify or how they have to work on developing or reorganizing their business models also. So all these factors have been considered in this project, okay. There were different work package. Each work package is quite big basically, and then the objective was that how we can use the real operational data from these houses for developing a tool and utilizing that tool for planning of the electricity network or the distributed network, where we are going to have such type of houses together. So it means that not only just developing a model, but it is based on the real operational data, then develop the model and feed this data and analyze that, yes, then we are okay. Then after that, we can use that as a tool for the further planning purpose. So here you can see that the research work which have been done here, okay, they are integrating the society into that, industries also, okay, and users also, and then academics also, because many master students, bachelor students, and the PhD students, they have utilized this data for their academic purposes also. Not only that, we used the findings from this project in our curriculum also. So in our teaching also, we have used that, especially for the master or the postgraduate teaching, not only just by taking one textbook and we are teaching, no, but we have taken the real data, real operational data. Based on that, we used or we developed our courses and taught the students and created the interest into the students for doing their project work, right, and contributing in this project and to the society also. Then another very interesting point is that not only from the technology point of view, but also we have to work from the business models point of view. Okay, so I hope that now we are at the, so I will just go briefly, because here you can see that I have given you some idea that how the energy production and consumption from these houses were from this one typical house have been there, right? Based on that, how the net zero energy definition they have been achieved here, right? So here you can see that in some of the periods of the year, or in some of the months of the year, when we have the cold climatic conditions or the dark days, maybe I can say. So during those dark days, basically we didn't have that much production from the solar photovoltaic system. But during the sunny days or the summertime, where we have very longer day length, we were in a position to provide more energy to the network. And of course, then we had to use a lot of computing techniques for analyzing all these things. Okay, so I think I will stop this today's lecture here, but tomorrow's lecture is going to be more interesting, with focused on use of information communication technology for aggregation of households, and how we can use ICT infrastructure for demand side management, especially in the domestic sector, and considering the centralized approach of virtual plant. Okay, so maybe I think now it is might have been getting bored also, like I'm speaking all the time and you people are at the receiving end. So now you should have some opportunity to talk with me and to get some ideas like what you think and how I can help you, right? So we need to have more interactive session now. Yeah. So now I request the moderator to ask or to open the questions from the participant, so that we can have some more discussion related to the key theme of the FDP.
Vandana.
Narayan, tell.
Sir, I just want to request any participants, if they are having any queries, kindly open your mic and ask it.
Hello, sir. I am audible.
Yes, ma'am, you're
I
audible.
can hear you.
Sir, I just want to ask you. In microgrid system, the renewable energy sources are very intermittent or very fluctuated in nature. And in that condition, when we apply the energy management system, is it economically feasible?
Yeah, that is a really a good question, right? I mean, I request that who is asking the question, please introduce yourself also.
Sir, I am Paramjit Kaur, and PhD research scholar under Dr. K.T. Chaturvedi, sir.
Very
And
good.
I'm here in TechCube also.
Very good.
So I'm doing some work in this area.
Very good. So, Paramjit, your question is very interesting. And number 2 or 3, my PhD students, they have worked on this topic also. And here the objective, like what you said, that to overcome the intermittency of renewable energy sources and include the energy management also. So here, my PhD student, they developed one very good architecture for that one. And that architecture is that how we can integrate appropriate capacity energy storage, okay, based on their dispatching rate also, and how they can contribute for dispatching the active and reactive power in coordination with the intermittency of renewable energy sources as well as the load. So they used here the Drupe characteristics, or maybe in a simple way they tried to make this solar photovoltaic system integrated with energy storage, for example lead acid or lithium ion batteries and supercapacitor, okay, because both have the different discharge characteristics also. And then they made this as an one active generator. So in simple way, it is going to operate as a virtual synchronous generator. Then the question comes, like, how we have to develop the power management strategy considering the Drupe characteristics. Okay, so that is a key question there. So one of my student, he developed that architecture, and considering the dispatch characteristics of supercapacitor as well as the lithium ion batteries, and the photovoltaic is as going to be as it is, and load also is going to be as it is, and then at the same time it is will also with the grid connected, so the grid constants also, okay, so cannot go above particular grid limit also, right? So that is a quite interesting point. And if you are interested in doing further work on this topic, so maybe I will share those papers with you and with Krishna also, and then maybe you can go through them, and then maybe we can have one separate discussion on that topic, and then I will try my best to provide you further inputs on your research work.
Okay, thank you, sir. Thank you so much. And sir, the Drupe control method is only feasible for AC, or we can use it in grid connected or islanded mode for both AC and DC?
Yes, we used for both grid connected mode also and islanded mode also.
And for both, sir, AC and DC?
Yes.
AC grid, AC microgrid.
Yes, that is quite good. We have one work on AC microgrid architecture, another work on DC microgrid architecture also. So in AC microgrid, we used back-to-back converters. So we made that AC microgrid more independent to the microgrid, and then from more independent to the main grid, and from the main grid, we just took only the active power.
Sir, I want to add one more question in this. Can we have to modify the Drupe control structure when we are moving from the grid connected to islanded mode?
Yes,
Are
of
the
course.
Okay, thank you, sir.
Because situation is that when you have the islanded mode, our grid source is out.
Yes.
Okay, so then we have to see the limits, because the limit is going to change then, and then
by that time we have to introduce some demand side management strategies also, might be.
There are two things. If demand side management strategy is good from the energy management point of view, okay, but when we are talking about the power management point of view, right, so then we are talking about the few microseconds, few milliseconds. So then demand side management strategy may not help. So that may go under the category of energy management strategy or energy management approach, let's say. And then when we are talking about the few microsecond level, then we have to come from the power management point of view.
Okay.
Yeah.
So we can also combine these two to get our grid more smarter.
Correct, because both has to be work, of course, integrated with each other, because we are using energy storage, and if you are using the conventional batteries and like that, so then we have to use that energy management approach to charge the batteries also.
Definitely, yes.
And then for power management, then we need to discharge them. So that is quite. Okay. So, and then of course here then we have to see that some scenarios like how the load prediction is there, how intermittent renewable predictions are there. Based on that, then we have to define our energy management strategies.
And sir, where we can find out the variety of work, because in DC microgrid there are so many parameters are very fixed, like frequencies and some other parameters are also fixed. But in AC, there are so many variations. So can we go through with AC, or it is feasible that only AC is suitable? Nowadays, what is
depending on the conditions, right? Because sometimes I feel that, in my personal opinion, mainly the AC microgrid will take place, and DC microgrid may go for like offshore applications or the off-grid application. Like for example, if you take the offshore oil and gas platform, now they are trying to move towards the DC based microgrid, and ABB is developing on that one also. So depending on the situation, location, and what type of loads are there, and like that.
Any more queries? Participants are requested to ask their queries. Okay. So there are no more queries in the chat box also. Yes, sir. I, on behalf of the entire fraternity and the organizing team, extend a very hearty vote of thanks to our eminent guest, Professor Dr. Mohan Kole sir, for gracing your important work and sharing with us your findings and expert opinions today. I must mention my deep sense of appreciation for his explanation of international research grants, which will definitely help in our academic and research work. He has also shared his research proposals and research projects. Really, sir, it's a very insightful and interactive session we have. We are all inspired by your great words. There's request for the tomorrow session. We have our next session tomorrow on 17 September at 10 a.m. So you are all requested to join by 9:50 a.m. before 10 minutes of commencement of session. For tomorrow's session, eminent speaker is Professor Sanjeev Ganguly sir from IIT Guwahati will grace the program. Thank you, sir, for sharing your expertise with us. Thank you all for your kind attention. Have a great day ahead.
Thank you, sir. Thank you, sir. Thank you, sir.
Thank you, Kitty.
Thank you, sir.
Thank you, sir.
Tomorrow at what time I have to give? Please update me, okay?
3 a.m. Sir, at
3 p.m.
At 3 p.m.
3 p.m.
At 3 p.m.
At 3 p.m.
Tomorrow then I will give one specific example of European Union Framework 7 project, which is really, really interesting project, okay?
Thank you.
Don't
Thank you,
forget
sir.
to miss that experience or to
Definitely, sir. It
learn
is
something from that project. Yeah.
Thank you, sir.
Thank you.
Thank you all.
Thank you,
So
sir.
shall
Thank you
we
very
now?
much.
Thank you, sir.